All right, good morning, good afternoon, good evening, everybody. Welcome to the Machine Learning Uyo series. And today we have an interesting session lined up for everybody. Basically, today we'll be talking about why AI coding agents break in real time. And trust me, I think this is one of the topics you really need to talk about. I mean, a lot of people vibe code a lot, and I vibe code a lot. And one of my greatest fear is after taking it to production, what is gonna happen, and what it most after a period of time, it doesn't just work as it's gonna work. Without wasting any time, thank you everybody for joining us today on the third session of Vibe Engineering Series by Machine Learning Uyo. Our speaker is here already, and our community admin, Agatha Ugo, is here. She'll be in the chat, managing the session, answering to your questions. So if you have any question, do well to drop in the social in the chat section. So when the video goes on YouTube, drop in the comment section. And if it's probably live stream, there'll be a channel to reach out to us. So before I proceed, and Anurag Wagh. So I mean, when first you saw the call for I mean, what inspired you to come up with this topic? Why AI coding in real code basis? I would like to hear one or two things from you.
like everyone do vibe coding now and it helpful and it write code fast, so we like I don't know about others, but I generate code, I vibe code daily. So but there are some problems we get in production too. So like now the shift is going from writing manual code to using AI assistant for coding tools. So this is a more important topic because we should know like how AI write code, because what we do, like we just generate code from AI and we without like testing it, without seeing it, we directly push it. But there are more things we should consider before pushing the code live. So that's what uh, inspires me to like talk on this topic.
I mean, that is really great. And I can see that you already prepared a whole lot for us today. I mean, so today I'm just going to be in the as a member, and I'm really ready to have your key takeaways from this session. Thank you very much. And at this point, I'll just do a brief introduction. So our speaker today, Anurag Wagh, is a product lead at Prepgrind and also the organizer of machine learning Nashik, right? So how is your community doing?
Yeah, our community is doing great. Like we have hosted our first hackathon last year in December, offline hackathon, and now it's going great. Like the response of students and other AI interests are like very much great, because like earlier when we started, the whole ecosystem of the community was not like that much active in our city. But now with the help of the Google support, also the work we are doing, other community also get activated and we are also supporting them. So yes, our community is doing great now. Like it's happy to share that we also got like most ML interesting community award like in 2024 in the whole Google ecosystem. So it's very honored us to like host our this community.
I mean, that's really a great news to share, and I really do look forward to more collaborations with us and more sessions with you. So without wasting any time, I'll just go ahead and give you the floor to start. Thank you so much. So you can proceed to share yours now.
Okay. Okay, we can start. Hello guys, how you guys doing? I hope you are doing great. So today we will be discussing how AI coding tools work internally, because like we write code a lot, but what happens internally, and is this like a right way to like directly push the code into the production or not? So Before diving, like who am I? So hello guys, I'm Anurag Wagh. I am product lead at Prepgrind. We do a lots of vibe coding too. Also, we use AI tools in our organization. Also, I'm an organizer of ML Nashik ML based community, which is supported by Google. And apart from that, I also published small tools and products live, like a ND dev. So you can definitely check out on my website anuragbag.me. So let's see what's happening in current era. So we have been seeing like the shift from writing manual code to AI assisted development. So like I know like just 3 to 4 years before we were writing just all, everything manually, and now like everything has changed. Like within a second, like we write so much code using AI, and that's the shift is also nice because we can iterate the whole production life cycle very fast. We can experiment things, we can check what works, what doesn't. But apart from that, there's also some concepts as things that we should consider before like writing code with AI. So before that, I just want to know how much you guys do vibe coding, or everyone is doing vibe coding. You can raise a hand, guys.
So I know that a lot of people do vibe coding. I mean, I know a lot of people who does that, but some companies actually don't want to. Don't buy the idea of their employees doing vibe coding. What do you think about that?
Okay, so like if you have seen the report out, I don't know. The more there are like three category of industry. Like first is which are on the top of the market. Then second one which are mid industries, and there and apart like below that there are startups like small organization. But if you see the top tier organization are already using AI tools in their whole production because it iterates the cycle. I don't know, like if you have seen the Cloud report, they had in numerous of deals with the finance organization, IT organizations to integrate their cloud code in their organization because production is getting fast in that. But if we see the mid-tier organization and small organization, they are not implementing. They have fear of not implementing, or they just neglected these things. But these things are the future, so we should consider that. That's happening because big companies know how to move fast. That's why they like iterate fast. They implement things which are going in the current market. So, okay, let's start with our presentation. So, what happens when we write code? We open IDE, like for example, if you are using anti-gravity, cursor, or cloud code, we describe what we want, like create a nice to-do application for me. So what it does, it generates 30 lines of code, 3,000 lines of code, nice UI. So what we do, we scroll a little, we look that the code looks very clean. Yeah, it's look very nice. UI is looking very nice. And what it's look professional. Yeah, it's working nice too. Impressive, na? So what we do, we run it. Then what we do, it working. Then we directly push the code into the production without seeing it. Nice, na? But there is the dangerous assumption that we just made. What assumption we are doing? That like blindly trusting the AI. Working feels like correct because at that feeling is what it's working. That's what our goal is. But reality is something different. Yeah. So is it like the AI is not smart? Like why does it fail? As I said, like the we just made a wrong assumption now. So is it that AI is not smart enough? No, it is not uh, that much smart. It's just of things. So let's like clarify what is happening. AI can write full functions, generate APIs, refactor components, even explain your own code back to you. So it clears like looks intelligence, but then it breaks on a small edge cases. If you written some production ready applications using AI, like you have occurred this any point of time, like it like directly breaks on the small edges cases. It may interpret the architecture. It changes something unrelated. It introduces some subtle bugs at the end or after some changes. So what's happening here? Like, is it a half smart, or is it a confused, or is it randomly guessing? But actually, yes, it's randomly guessing, but not fully, but it's doing something very specific, rule-based things. Let's say, okay, when we give a prompt, what actually happening in the background? Now we will discuss that, because this is a very important thing, because we just give the prompt, it generates the code, and we directly push to the production, and we saw that errors are solved, functions is working, our process is done. But no, there is a something things that we should know what happening internally, because once you know, then you will not push the code blindly, you will not trust the AI blindly. So if you can see this, we have architecture, transformer, inference workflow. If I can zoom it. Yeah, I guess, yeah, it's visible. Okay. So when the movement happens, when we give the prompt, what happens? When you type code and AI continues it, it's not thinking about the architecture you said, like we want the data to come from this, and it goes to this pipeline, then the processing happens, and then, yeah, we are getting output. No, the AI is not thinking about the architecture, not simulating your app, simulating your app. It's not understanding your business logic too. It's just doing one thing, predicting the next token. If you have learned about the CNN, RNN, SIN, it's just predicting the next token. Nothing else, not like checking the whole code. What is your business logic? What is the architecture? What is the uh, variable type, and of just doing one thing, which is the predicting the token. But what is a token? A token is just a, you can say, it's a small piece of text, sometimes a word, sometimes a part of a word, or sometimes symbols like braces, circle braces, and all. So what's model really does this? So you give it some text, context, and your existing code. It passes through a neural network called a transformer. If you can see on the first architecture, that we give a prompt, then it goes to the transformer model. Then what this does, it passes, it iterates through every node of the CNN. So what is most likely is the next token it's gonna generate. Then that token is added again to the input, and this process repeats continuously, means just generating token, and that's how your entire function is generated. Mean it's just predicting the token, nothing else. So when AI writes 40 lines of function, it didn't plan 40 lines, like it just predict them. Not like, yeah, I know that I have written the addition functions, and now this function has this. No, it's just predicting the things one step at a time. So next thing, if you see, we have another architecture. This is how our transformer model means, whatever AI models you are seeing, like GPT, like DeepSeek, Claude, or any other model you are seeing. This is how they are. We know the model predicts the next token, but how did it learn with this architecture? How this is it has trained over the time till now. It was trained on massive amount of text and code. If you know the meaning of the GPT, which is a generative pre-trained model. What does pre-trained means? Already trained on some massive amount of data. What data, text, and code, like GitHub repository, then documentations, articles, forums, everything, means whatever available on the internet, it has given to. So now what happens during the training, the model sees a part of the sentence or a code snippet. For example, let's say I want to write a function add. Okay, what it has two parameters, a and b, and what is written, a plus b. Okay, so what we will give a small uh, what we will give a small line to the model. For example, function add a b parameter curly written a plus, just that's it, nothing else. Now what will happen when the input goes to the model, and it iterate through the neural network, then it predict the next token. What is the next token? The correct next token will be b, because we are returning the addition of two numbers. The model predicts something, maybe it predicts the another, but moreover, it has trained on the massive data. It predicts right, because once, for example, once we uh, go through one concept 1,000 times, we can predict things. That's what it does. So maybe it predicts something else too, but not happens because it has given the innumerous of data. Because of that, 90% it predicts same thing. Then it compare its prediction with the actual correct token. If you can see, we have, yeah, here. Okay. So when we calculate something called loss, when it compares through the correct token, we calculate loss. What is loss? Loss is just a number that tells the model how wrong it was. For example, if we say you want to take a right, then again right, then you will reach to the goal. But if you take another turn, like right, and then you just take the left, then you will miss the point. Like a game, when we play the game, we have the plus minus point. Same thing. We have to just tell the model that when he takes the right direction, we just reward it with him the nice points that, yeah, you are doing right. That's what it does. So loss is just a number that tells the model how wrong it was. And then what happens? If it was wrong, we adjust the weight. If it was close to that, means almost the what the token it is predicting, we adjust the less. Okay. And as this happens millions of times, means uh, the neural network is not just 4 nodes, 5 nodes, or 10 nodes. It has billions of nodes, billions of parameters, billions of functions which it generates. Okay. So what models training is? Not logic, not architecture, just no correctness. It's just learning what token is generated. Okay. Means what is it? Is basically a statistical and probability, nothing much more. Like the model is trained to reduce prediction error at the end. It is not trained to ensure that your code works in production or not. It's just like predicting the things accurately, so you will have the right code at the end of the time. I hope you guys get that architecture. If not, we will again see little bit later. Okay. So now this is more important because what we have seen first, now we have seen the architecture, how the flow chart means how it has trained on them. But now let's see how model was trained to minimize the prediction error. Because as I said, like it just predict, then compare it is the right token or not. But how this prediction error we are optimizing, which means we reward for producing code that looks highly probable. Means, for example, if we say him like write a Python code to add for addition two numbers. So highly probability is that this is right. What does probably mean? Like it is a common things like common pattern, frequently seen structures, or you can say code that looks like example from a training data. When if you have trained some small models, you have to give a training data to like train on it what actually he want to predict, or what the actually output he want to generate. So what does that mean? Code that looks explain from the training data, not just randomly thing. So if most GitHub repository uses a certain patterns, or any forum, or the code which we have given has a certain pattern, the model becomes very confident that this is a pattern and this is a token I want to generate. Like for example, if you have written, if for example if you have read some articles 1,000 times, same from 1,000 website, then you are likely to know that what will be the next thing, what will be the next word it will have, even if not perfect for your situation too. But this is what happens. And here's the problem too. Software engineering is not about the probability. Like it's about the correctness. We can't ship a product based on the probability. Yeah, it's working. Because if we stay on the probability, then the product will never be in a production for use of the users. So it's not about the correctness. It's about the properly making the product in streamlined correct. What does that mean? Does it handle all edge cases? Because when we are white coding, we doesn't provide it all edge cases that this type of input is allowed, this type of not. What will happen if certain input we have given, certain cases will occur. We just write the code, it's just generating, yeah, it's working and done. But we have to also check the all edge cases because we are pushing the production ready software, and this can be a number of things that can happen at the end from the user end. So next, what is, does it preserves the invariants? Does it break something else, or does it can scale? Because it's important. We don't have the 10 users or one user. We can have the 100 users, 1,000 users, lakh users. So is it scalable or not? But the model, what model two is, model was never trained to care about this thing. It was just cared about why, what to predict things, and that's the work of the model. The loss function we talked earlier was doesn't include a term for a future bug. Like it doesn't include a term for architecturing inconsistency, because that's important now. Because we are building a product, we have to maintain the architecture, we have to maintain the flow, we have to keep it in the consistent thing. But it doesn't do that thing. This is show that what we are missing from the AI code. Oh, yeah, as I talk, like model doesn't care about what we have, our our business logic, our the architecture. But for example, if you are like, if you are working in an organization, or if you are one who are building a product or having your own organization, or you are doing some freelance stuff, first thing what we ask is what will be the flow, what you want, what is the product. After that, what we say, how input will be given, what will be the cases, what will be the security flaws, and then we write the all the test cases, all the parameters, all the we draw flowchart diagrams, we create a UI UX thing, we create a PID and all, and after that it goes to development, right? But when we are vibe coding, do we do that? No, we don't do that usually, because software requires consistency across the entire system. We don't know about that. We just know like it's generating output and we are getting something. Yes, it's working. That's it. No. For example, I don't know if you guys have experienced or not. If I change one file, it should like it silently break three other modules too, and there is no connection between them, but still it just changes other modules too. If I refactor something, it should like preserve the behavior, but it doesn't. If I add some feature, for example, so it should violate some hidden assumptions too, as I said, like we have to see all the edge cases, but it doesn't now. This is a system wide invariant which we often see, and this invariants are not visible in one function. They are spread across the whole system. So if you like just sit and just find out all the debugs and all the like see the code, you can have so many flaws, small bugs and things which need lots of time to solve. So now the point is that software is a global, model are local, as I written. Because what does that mean? The model just predicts one token at a time based on the context it sees, which we provide. And it doesn't simulate all the future executions, all the possible inputs, and all the interactions between the models. It works just locally. We are predicting things, but software needs a correctness, which is a global thing. Global means not world global, means the whole production life cycle of the product, means from all the features, all the architecture and flowchart. That's what I mean from the term global. Okay, next we will see like the context window limitation. I don't know if you guys have seen or not. In anti-gravity or cursor, we have one bar of loading bar, bar in the right side where it shows how much context it has filled. If you didn't see, just go once to anti-gravity, or you can see on the cursor ID too. I use a lot. there is a context window, and it's a very important thing, uh, because if you guys are using AI tools, you have like occur that in some days or some time your credit get exhausted, and you were like, yeah, I just generated this much code only, and it has my all the credits are over. But there's a thing behind that which is going wrong. So many, I don't know, you guys don't know, but many people also get surprises related to context window. Like, what's that? AI doesn't actually see your entire project. It just see your input and the context which we have given. For example, this is your whole code base, if you can see. And there are, for example, n numbers of files, utilities, hidden dependency, configuration, states, and all, everything. This is what model says? No. Model what says is just a small thing, which you can see in the diagram too. Just a small thing. Now you like when you write the code, you are just worried that I want uh, the function which is connected to this files and utilities, but it is not working on like it's not maintaining the flow. What's happening? This is what the model sees. Like it's just a limited number of tokens, maybe a few thousand lines, maybe a few lines. For example, if you have seen GPT models, I don't know about now, but GPT-4 and Sonnet 4.3 model was having around, GPT was having 128K context window, and Sonnet was having 220K context window. So when we give an input, what is this? I will give a very simple example. For example, you have a 120K context window. So when we give an input, it will take? It will take your input. It will take your code files. So this will create some, for example, it has generated 20 to 30K tokens. Apart from that, what is required? It requires all the cache, all the work which it has done till now, or the other files. So this, what is this? It take from everything and then goes to the server through like the limit. For example, if limit was 128K, so it has like pulled around 80 to 90K. Then it takes everything and goes to the server, and it processes everything based on that context, and it gets back to you and give the output. But in some situations, what happens? The context window get exceed. For example, you have uh, tokens which are of 200K, and the context limit was just 120K. So what? Model takes and it just go to the server with that 120K context. Yeah, context tokens. Now, what is happening? Yes, 80K context tokens are lost. It are like model neglected, ignore it, because it doesn't have that much. We eat we eat food that like we eat food the capacity we have. If we get the food apart from our capacity, we don't like eat that. Same thing is happening in the GPT models. So when it makes a decision, it is making that decision based on the partial visibility. Now, like, imagine reviewing 10,000 lines of project, but you are only allowed to read 500. So you will judge, or uh, you will like you will have something related, like context of just 500 lines. You will judge, you will solve based on that 500 lines only. So other 9,900 and 500 lines of code is neglected. So that's what is happening. So context window is very important. Transformer models operate within a context window only, and this window limits how many tokens they can process at once. Anything outside that window is invisible to the model. So context window is very important. Till now we have seen, but next we will see, apart from that, the local prediction problem. So what is that? Remember, as I said earlier, the model predicts one token at a time. So what happens? If you can see in the diagram, step one is it predicts something slightly off, maybe not totally wrong, just slightly imperfect. Now, in step two, it predicts based on that slightly imperfect output. So, in step three, what happens? Build on top of it again. So, one mistake at the beginning, it changes everything. Means other future things are also get messed. That's why the predicting the first token and comparing it is in the beginning is very important because it's an auto aggressive. Each new prediction depends on the previous prediction. So a small mistake earlier can influence the entire rest of the function, and that's the error compounding thing we like see everywhere. Language models are auto-aggressive. That means each token is generated conditionized on previous token. So there is no like a global verification step during this generation. This is no like built-in logic checker. There's only like means no invariant enforcement. The model assumes just previous output is this, so I am need to predict this, and this output is correct or not. Just compare dash token and just the cycles iterate. So autoaggressive generation means mistakes don't reset, they propagate. Yeah. Now, why it like mislead things? Here's the trap we will fall into always. Like you generate code, you run it, it compile, it doesn't crash. Okay. And your brain says, nice, it's working nice, the UI is look nice, my input is going, everything is nice, it works. But what does work actually mean? Means just given the input and it's generating output? No. It means it didn't fail immediately? No, that's not me. That's where we just make a wrong assumption. It does not mean that all edge cases are handled, future updates won't break it, or hidden assumptions are valid, performance is correct, or security is safe or not. It just means the execution path did not crash. Deep learning models are trained on a full system simulations. They are trained on a token prediction. They are like have no DOS term that says, does this code remain correct across the future states? The model has no memory of your production data, no understanding of runtime dynamics, no simulations of state transition. It cannot test your system in its head, like it cannot reason about long-term consequences. Running ones is not just proof of the correctness. That's what we want to focus on this slide. So let's take a small example. You give the code, like you give the input to the AI, like write a function for me. Now it's clean, proper indentation. You can see great variable names, nice comments, even like error handling. It looks like a senior developer wrote it. And because it looks professional, we trust it. And that the fluency illusion, we can say. Deep learning model are trained to produce text that feels natural and coherent. But what is happening? They're extremely good, like style, formatting, syntax, confidence. Like we see, yeah, this code is looking nice. This like has a nice comments and nice variable name. Because as a CS like engineer, you were said like you should always have proper indentations, comments, and a variable's name, nice name. That's how you write the code. But the model is optimized to minimize the token prediction loss. The naturally produce fluent, high probability sequence, fluency emerges from training. But correctness, this is not a directly optimized thing. Nah? So if you can see on second slide, here is the thing. Like it has so many errors. If you can see the total sum, if you can see here, it has a price keeper missing some mistyped thing. There is a bug in this line of like the tax before discount. So this is what happening behind the scenario. It's just the we just write the code. It looks nice. That doesn't mean it's right. We have to check out the first. If you have seen on some freelancer site too, or companies hire sometimes in small companies, not big organizations, because they have already engineers. So there's a term called solving, not solving, just minimizing the AI generated code. The Because AI generates lots of code, so there are some role which just who just minimize all the mess of the AI generated code thing. So this is the AI agents architecture. We see how model works. Now let's see some how AI agents architecture work. Because after the model gives the output to the AI agent for writing code, what's happening? So for we just talk about the uh, AI generating one function, but more like modern tools don't have this autocomplete. Now we have to write another code too. We have to move from UI to backend, from terminal to everything. So this is not like an agents. Okay, you can see. What does that mean? Instead of just predicting token once, they have to plan some changes. Like model just generate output now, but what our AI ID is doing so far, it also changing the output, sorry, code which are already generated, also editing files, then running commands in terminal. If you have seen the anti-gravity or in cursor, you just run the comments, run the commands in terminal automatically. Now anti-gravity also observe the output, like from going to browser and checking all the UI or the function is working or not. It try to fix some errors too, and this happens repeatedly. So this is how the probabilistic chains is working on. We have a loop, yeah. And there's a critical part too. Each loop step is still powered by the same deep learning model, like still predicting a probabilistic and a local thing. An AI coding agent is typically structured like this. You can, if you can see, planner, which decide the next action, then LLMs, which generates code or reasoning, then tool executor, which applies changes or run codes, and then feedback. What is the feedback? Output is feedback into LLM, and this creates a closed loop. But the LLM itself hasn't changed now. It is still predicting the token, optimizing the same thing, and doesn't track the global invariant thing. For example, imagine AI misinterprets your data structure in step one. Now in step two, it tries to fix error caused by that misunderstanding. And in step three, it tries to fix step two. Each step is internally consistent. So, but this foundation is wrong. This is how the subtle chaos grows when things start like happening from the beginning. If you can see, oh, I just okay, like this diagram and this diagram is same, but here what we have to focus on this loop cycle. I just pasted the same diagram. It's the same diagram, just here we have the red marking to indicate what's happening. So if you can see, just assume that we are just talking about this plan from the planner to tool executor. So an agent doesn't just generate code once, it make a sequence of decisions. First, it predicts the plan, then it edits the files, it run tests, it read outputs, and it predicts what to do next. Okay. And every single one of those steps is powered by probabilistic model. As I said, that it's just doing probabilistic statistic. Meaning each decision is based on the likelihood, each action assumes previous output is correct, there like a ground truth verification engine inside. So because language models are like autoaggressive and probabilistic, so when used in iterative loops, uncertainty accumulate. This is like similar to, you can say, error propagation in sequential systems. If you have seen about the sequential system, there is an error propagation thing. The model doesn't know, like when it's a foundational assumption is wrong, it just keeping building on it. Sometimes it's also hallucinate. If you have seen about like it's just generating one thing, one thing, one thing, one thing. Agent feel autonomous, but there are still some statistical guesses. Like for example, let's say the agent misunderstood a configuration file earlier. Now it keeps editing other files to fix same problem that are actually caused by its own misunderstanding. Like for example, I don't know you have done or not. You have, like I have done lots of time. I have to tell the agent that you are doing this wrong, or this method was wrong. You have done it this. So at that time, the model get to know that yeah, he was doing right. Each fix introduce more uh, evidence to from the reality, and because the output is fluent and structured, it looks controlled, like, but underneath the assumptions are drifting the same thing, same thing, same thing. We have, for example, let's compare some mm, situations. For example, you start a brand new project, modern framework, clean structure, standard patterns, everything's like a GitHub examples. AI performs really well here. Why? Because it has seen this before. As I said earlier, it has trained on massive amount of data that also include the GitHub repository and all. So thousands of times, millions of times it has trained. Now it looks at the right now because it's working nice. A real company project like has years of commit, mixed like coding styles, temporary hacks, business logic that evolve over the time, hidden assumptions. That environment looks like nothing. I will show that example after that. Like I have an image which shows when things get complex, how models ignore that. If you have like working on same project with the AI for a long time, so you have came to a point where the repository gets big. You have a tons of files, libraries, utilities, and all, and it just start ignoring. It doesn't know how, like, what is going from one flow to another flow, and this happens when the product grows. If, for example, I get a to-do app, a simple to-do app, agent can solve that because it know already how to work on like what's a to-do app and how it's made. But for example, if I gave him how the Meta product or Google's any product is working, it can't do that because it's not trained on that thing. Okay, so this is something called distribution shift. Like the model was trained on like certain data distributions. When your project deviates from the distributions, performing degrades. So most training data follows same a pattern, and then it goes from training to another things and all. That's what is happening when you are trained on something. You know about that, but you don't know about another thing. Either you give up or you just guess what's happening. That's what happens. I have done 2 months back. I was working on some ML project. So it was like something like we were creating some new architecture. So it was not able to build that because it was not trained on that thing. It was just trained on the same whatever till now it has given. So everything we discussed, context limits, token predictions, error compounding, distribution shift, all of it comes from one fundamental fact, that is deep learning models are statistical pattern learners. They learn correlations, they learn what usually follows what, they learn what code tends to look like, but they do not track logical invariants, maintain a symbolic model of your system, which is important, prove correctness, simulate long-term executions. They don't build a world model of your project. They build a probability distributions over a tokens. And that difference matters because software engineering requires constraint across a time, then logical guarantees, then architecture intent, explicit reasoning, and statistical pattern learning alone cannot guarantee those properties. So this is how the deep learning models is working. So after everything like I have discussed till now, how you can use AI models. This doesn't mean like to stop using AI. No, AI is incredibly powerful, but we need the correct mental model. If you look on the left side, we have boilerplate, repetitive code, common framework pattern, and syntax generation. These are a right probability zone where you can blindly trust on that for generating, not for the production. We have to check at the end too. The model has seen this 1,000 times, so it can predict the same thing. So that's why the we say that this has a billion parameters, this has a trend on this data, because training data also matters. The more training data quality ensures the output of the model is that much great. So it performs very well there. Now, if you look at the right side, what is needed? Architecture decision, core logic, security sensitive code, business rules unique to your system according to your thing. And these are low frequency, high impact decisions that we as human have to take. The model has a weak statistical grounding here. Like it can't see your business logic and all that thing. In high frequency regions of the training distribution, model confidence is meaningful. In rare or unique regions, confidence is just misleading thing. And that's it. I guess this is the summary of what be going. Why does AI sometimes act incredibly smart and sometimes completely break your project? Is because it's doing exactly what was trained to do. It predicts what is statistically likely and probability of for producing a next token. It does not reason about the invariants, simulate your future bugs, then understand your architecture, not maintain a symbolic model of your system. It generates just high probability sequence, and most of the time, high probability aligns with the good code of generating the tokens. But when your project becomes the complex, unique, fragile, probability is not enough. You have to and that the thing, like you have to check thing. And that's the key idea. AI is powerful, AI is useful, AI is impressive, but it's still a statistical model. It's not a reasoning engine. It's not a software architecture. It's not a verifier. Use it's just a model to generate a token. So use AI aggressively, but never outsource understanding, which is the work of human, and that's very important. Yeah, that's it. Pretty much I have covered how models work and everything goes. Uh, I have kept this very beginner friendly, as like you guys are just like as I told, like there are audience who are getting into it, and these are the very important things. As a vibe coder, you must understand how the backend thing is working, because blindly trusting things can't be make a right product. Yeah, that's it. So if you guys have any question, just let me know in a comment section, or you can just unmute.
Uh, Thank you very much for the session. Can you hear me?
Yeah, yeah, I can hear you.
Yeah, I've taken a lot of things away from the session. So I mean, it's more. I've gotten a lot of key takeaways. I'm like, all this I didn't know it like this. I know we do I do vibe coding, but I didn't have this, insight and breakdown the way I really do have today. So I mean, I'm just being tempted to ask, how long have you been doing vibe coding?
Like which tool you guys use for vibe coding?
How long? Yeah, so you have a feedback here. Um, thank you, thank you
Like
so much.
that's a nice feedback. Like I hope like
Yeah,
you
yeah,
find
yeah,
it
yeah. So,
useful. That's great for me.
all right, great. Uh, can you send the slides to us?
Yeah, I can share the slides. Uh,
Okay. So do we have any questions so far? Is there anybody that wants to ask any question? I don't really. Okay, yeah, go ahead.
Yeah, yes,
Can
yes.
hear
Thank
Hi.
you so much for the presentation. Yeah, I wanted to ask, so now based on some of the limitations that we've actually highlighted, or I want to ask, so what's the best way to do vibe coding? What are the necessary steps to take into factor? Because now these days they are bringing something like scales and workflow. So how then do you like leverage these things to make code is actually accurate and correct?
Okay, so like which tool you are using?
Mostly these days I use anti-gravity. Yeah, then maybe on some quick projects I use Firebase Studio. Yeah, but it's mostly anti-gravity.
Okay, so see, like as I said, like while, for example, if you are building something already on the project you have, not from the scratch. So at that time, what is important? First thing is knowing, like to know your model, what is your project. So, for example, if you have already one project and you just gave to the model that now I have to work on it. So first thing is to you have to give the clear picture of what your product do and how what is the architecture and what is the flow. Like what it will do is it will know which files are doing what and which code is doing what, like how the flow is going. Next thing is you have to manage the context. Context means like, for example, if you are just randomly prompting now, you have the big repository, then it will consider different things too. It will change on other files too. So for that, you have to maintain the context. How you maintain the context? First, just give whatever the files, whatever the code, whatever you have, want to implement, and that's it. Apart from that, don't make it consider to give it to the model. It can also consider other files too, but you have to maintain that context. You can just mention which thing, like you can share the files, so you can share the code. There's one also uh, thing you can do is you can also use the git, like ignore files, git ignore views. We have the agent ignore file, agent rule files, where what you can do is like what I do, like I have a big repository where I added all the files into the ignore. So what it does, it ignore all the files, so it doesn't look into that, it doesn't edit into that. So what I do is I just uh, give the file names which I want to edit or work on, and I kept all the files codes in the ignore file, so it doesn't consider that. I also write rules in my rule file is that the files in the ignore I have mentioned that are fixed files, do not touch it, do not edit the code, and that you can do. And if you are building something which is a common thing, for example, something model which you can see, for example, if you have an architecture in that with things which are implemented till now. For example, CRUD operation is the old thing. It has been developed from a decade, so it's a basic thing. For that's why model can do CRUD operation easily. So always think that if you in your architecture, in your product, the things which you are going to wipe code are common or not. If they are not common, then means if you are generating some new architecture, then what it will do, it will code which are based on the common things, it will predict, uh, you can, it can guess. Then that's you, on that point, that's your take to check the what is the code it has written, how the flow is going. And if that's not a case, that everything is based on the past architectures and past framework, then you can just go through that once. After it has generated, check all the code what it had written. You don't have to like go through everything like character by character, but check what function it has written, what output it has taken, does it has taken the all the cases or not. And this is how like the understanding also grows for you too and model too. I hope that you have get the thing.
Wow. All right. All right. All right. Thank you so much. Thank you so much. Thank you so much. So I'll get your contact then. If anything, I would always want to connect so I can get more from you as well.
Yeah,
Thank you. Thank you. Thank you.
yeah, you can connect and you can ask whatever you have question.
All right. Thank you
So
so much.
I don't know if I can ask my own question. So basically, um,
Yeah,
I don't really know how to frame my question because most times I go out, I run out of tokens a lot, and changing models, does it really affect a current a particular workflow or session?
yeah, that's happens because if you are using anti-gravity, like first always check which model you are using, how it works. For example, currently Claude Opus, it's a best model. But if you are using some mini models like Flash, or if you are using Cursor, there has some small models too. So always check how how the model is trained, and how like what parameters it has. So once you get that, you will know that the model is generating that type of code. So if you are using some small flash models, then it can generate code which are not fully optimized. It can generate the code which can work, but it's not optimized according to what we will need for the whole production lifecycle. And talking about the as you said, your token gate exit. So as I earlier said, like for to the mark question, you can always ignore all the files. For example, if you are using React, uh, it has a node modules too, so it can consider that, it consider that too. So always uh, mention only things that you have to work on. You can use ignore concept, where you just ignore everything and just work on the specific thing. Also always check your cache, because whatever you have built till now and about the project, the model like AI model, agent model, always have the cache of everything what we have built till now, what is in. So even your context has a limited tokens to take for the processing in the server, but it has also the cache behind that, which it has to consider about, because it can't just blindly go through that. It need also some other context of the file. So that's why cache it generates, which is very important. So you can if there is an unnecessary cache, you can also minimize it. You can like frequently just delete it, which will make your context low too, so which will save your credits.
Okay, thank you very much. That was really helpful. So, is there anybody? Do we have any question now? Before we wrap up this session.
Like I have shared the slides links too, you can just visit if you
Yes, so
want.
I've seen the link to the slides. I'll just share it again for those that just joined. Okay, so I've just reshared that. All right. So in the absence of any other question, thank you so much for joining us today. The session was really really great and it's really practical. Uh, the recording of the session will be shared with you and everybody on our YouTube channel. So we have created like a playlist vibe engineering series where all our session will just fall under here. And this is our tech session. So thank you very much for accepting to be a speaker for today. My regards to your community.
Yeah, thanks for inviting me, and you are a lovely audience. Let me know if you have any question. And vibe code is a thing everyone loves now. Like nobody wants to write manual code now. Everyone wants a quick output. So yeah, thank you guys. Thank you for joining us today and listening it. If you guys just posting it on social, don't forget to tag me, tag the community too. Yeah,
All right, thank you very, very much. Bye. Bye, everyone.
bye everyone. Thanks for joining.